Hi guys, welcome to today's recording. We'll be going through NCEA Level 1 Mechanics exam that was done in 2021. So one thing that you notice that all of the equations are given at the top of the page, so you need to be very familiar with what they stand for and when to use which formula, because most of the time it's all about just substituting number, putting the correct formula down, substituting the right number, and then put the right numbers in, do the calculation properly, and then write the unit, and then you're good to go. Okay, so let's get started. So the first one is a distance time graph. So whenever you get a distance time graph like this, so that means for section A, so this is showing a does that line look straight? That doesn't look very straight. So when you have a curved line like that, this is showing acceleration. And then for this bit here, this is a straight line, so this is constant speed. And then for this bit here, so that's showing deceleration. And then for section D, that is just stationary, because the speed, the distance covered in that time is 0, so there's no speed. Okay, so stationary. And how long did the journey take? So you just literally look at the graph. So how long did the journey take? Zoe ran from I don't know what she was doing, but I think it's up to here that she stopped moving. So this is 240. Okay, so 240 meters. So at 240 meters, she has stopped, and that's her total distance covered. So the next part, calculate the speed in section B. So to calculate the speed, this is what you can do. I always recommend just look at the last point, look at the first point, and then what you want to do is you look at how high it went up by, and how low, how wide did it go. Okay, so I think it's over here. That looks right. This is the last point, and this is the first point. So this point is on 300, and this point is on 2200. Okay, so how far, and this is, I can't really show this in front of you because you can't see me, but what you could do is I always tell people to put your just to put your hand above, just on top of the paper, and just do it like this. What is the distance vertically from this point to this point? So it's from here to here, right? So it's 12, so it's 2200 minus 300, so it's 1900 going up. Then going across, you are going from 40 to 220. So you went from 40 to 220. What is the distance between that? So rise is this number, run is going to be 220 minus 40, which is going to be how wide the thing is. So it's going to be 180. So, and then you just take a division of the two, and that's how you can get the final answer. All right, so let's have a look. So this is going to be 2200 minus 300 divided by 220 divided by minus 40, and that's going to give us 10.55. Make sure you put the unit down, which is meters per second. Okay, now another race is 3,000 meters long. Her average speed is 5 meters per second. Calculate average time. So this is where you're going to use distance equals, if you look at the equation, speed equals distance divided by time. This equation is up on the top, and to figure out time, you just need to rearrange it, or even if you don't know how to rearrange it, just substitute numbers in. 5 equals 3,000 divided by t. How do I figure out t? Now this is where I always go, if you can get to this part but don't know what to do, technically your science teacher's job is done, because we taught you the science, you know how to use the equation. You should technically ask your math teacher for help from this point. Okay, so you want to make this a subject, so shift t to this side, it's dividing on the other side, so it's multiply on this side. That's going to equal to 3,000. So t is going to equal to 600 seconds. Make sure you write a unit. Any number that you write down without a unit in science, there are a few exceptions here, but majority of the numbers you write down should have a unit. Without a unit, they don't mean anything. Okay, I personally marked this exam last year, And I can tell you this question is like an excellence question, which is a joke. Like, it's ridiculous how easy everything has become. So I've always told my year 11s that mechanics paper is by far the easiest paper to do well in, because there's very little explanation. Most of it is just calculation. So you just need to, know your formula, learn which one to use, and then you should be okay. Okay, so we're calculating pressure. Pressure is force divided by area, so you need to find the force. The force is right here, 570. The surface area of one snowshoe is 0.15. The surface area of one walking shoe is that. So for one snowshoe, it's just 570 divided by 0.15, and that's going to give us 3,800 Pascal, PA, not P. P is not the correct unit. For this one, it's going to be 570 divided by 0.03, and this is going to give us 19,000 Pascal. Okay. Okay, so if we look at the second part of the question, it is asking us to explain why snowshoes is easier to walk in the soft snow. So if you look at the snowshoe has got less pressure, because from the calculation that we done over here. And then because it has less pressure, why does it has less pressure? Because it has a larger surface area, which you can see here. This number 0.15 is bigger than 0.03. So we have a larger surface area. That means we have less pressure, and that means you will sink less. Okay, so if you imagine, if you've never been on a snow trip or being overseas, but imagine walking in snow, you will sink into deep snow if you have too much pressure. Okay, so it's often quite nice to walk around in snowshoes that has got larger surface area that distribute your force more evenly spread out, so you don't sink into the snow and then get wet feet, because that's the last thing you want. Okay, so you can see here the weight is the same because it's the same person, but then because the surface area is greater, there's less pressure, and you don't sink into the snow as much. Okay, so let's go on to the next question. So this is question 2. So let's have a look. So Pete and his climbing equipment has a combined mass of 80 kilograms. So if you know the mass, you know the weight. It's just 80 times 10, which gives you 800 newtons. Mass times gravity gives you the weight, and it's just always the kgs times 10. Just remember that. Okay, now explain the difference between mass and weight. Mass is the amount of object, like amount of matter and material that makes up a particular object. Okay, so if you have a mass of say 60 kilograms, if we put you on a spaceship and send you to the moon, you will also have a mass of 60 kilograms. On a different, just because you're on a different planet doesn't mean you will have a different mass. You don't magically gain or lose mass. But what has changed is weight, because weight is the amount of gravity, amount of force that is acting on a mass. Okay, so that's very important. So here it goes, the mass amount of material, whereas the weight is the amount of force that's acting on the mass due to gravity. Okay, next one. So Manaya is 100 meters from the bottom of the cave. Her 1 kg torch falls out of her backpack. Hopefully no one's underneath, because that's gonna hurt. Calculate the gravitational potential energy. So this is EP equals mgh. You just substitute numbers in. Okay, the torch, what's the torch? 1 kg, gravity is 10, height is 100 meters. You literally just substitute numbers in. And then if you can do this is like a mirror question, just as simple as that. Even if you look at the marking schedule, I was so surprised last year when I marked this, is that if you just put the equations in, we will give you a tick, and you just need like 9 points to pass. So it's getting easier and easier. Okay, now what type of energy? So this is EK, kinetic energy. Now calculate the maximum speed. So this is where you assume that EP has been, all of the EP that we calculated here is converted to EK, and that equals to 1,000 joules. Okay, so how do we calculate EK? EK equals half m v squared, which is all going to be equal to 1,000. So half times mass, which is 1, times v squared equals 1,000. And then and then if you actually look at this, so v squared equals so this is 0.5, so v squared equals 2,000. V is square root of 2,000, which is going to be 44.7 meters per second. So make sure you put the units in. No units, no merit. You can just remember that, okay? Because I've seen some people that did the entire exam paper without putting a single unit on the answer, and the person got achieved, even though that person probably did most of the questions right and would have comfortably gotten merit. But then because you don't write the unit, you're showing no understanding in science, so you don't get anything higher than achieved. Okay, so calculate the work done by Pete and Manai. So Pete is on top, M is here. So calculate the work. Work is force times distance. So what are they doing? They're climbing up. So when you're climbing up, you need to overcome the weight force. Okay, so how do we figure out the weight force? If Pete weighs 80 kilograms, his weight force will just be 80 times 10. And how high did they climb? Times 170, and that's going to give us 136,000 joules. And for Manai, it's going to be 75 times 10 times 170, and that's going to be 127,500 joules. The two materials. Excuse me. So that's going to be the work. And then we want to calculate the power. So the power is work divided by time. So that's going to be 136,000 divided by time, which is 2200, and that's going to give us 61.8 watts, which is W. And for this is Pete, and then for the girl, it's going to be same thing. Power equals work divided by time, which is going to be 127,500 divided by how long did you take her? 2,000 seconds, and that will be 63.7 watts. Okay, so the really important thing that they ask you to do in the next question, explain who does more work and also uses more power. So if you look at these two numbers, Pete over here does more work, but Pete actually does less power. The reason that he does more work is because he has a larger body mass. That means he would have a larger weight force. Because they are climbing the same distance, the weight force is the determining factor of how much work they do. So in this case, a larger person would obviously require to do more work to pull him out of the cave. Okay, now, but because Pete, now when we look at the power, why does why did she do more power? Why was she more powerful? Is because even though she did less work, but her time was quite short. She used significantly less time compared to Pete. So even though she did less work, but then she did it in less time, and then that worked out that she's more powerful. Okay, so that's how that question works. Excellent question there. All right, so this is question 3. Going on to question 3. So what is the maximum speed? So this is a speed time graph. What's the maximum speed of the dragster? This is going to be right here. So it's going to be 200 meters per second. Very nice and easy. Using the graph, show the acceleration in the first 4 seconds. So if you're looking at this particular section, this is constant acceleration. This part is constant speed. This part is constant deceleration. And we can calculate acceleration by using the first point. By using the first point and the last point. Look at the rise is 200. Look at the run is 4, so 200 divided by 4, and that will give us 50 meters per second. Don't forget to put your units in. Okay, now we know the mass is 10 over 50. Calculate the force required. So this is where you just go F equals ma, substitute numbers in. So this is where all the trick is. Find the formula and substitute numbers in, and then you will be successful in NCEA level 1 science. Okay, so mass is right here, 1050. Acceleration is right here, 50. And then you may go, so how do you know this is acceleration? This is where you need to look at the units. You know, this is where your basics understanding will come in. So this will give us 52500 newtons. Okay. Right, look at the next part. On the horizontal, on the diagram below, draw the label diagram to show the size of different. Okay, so if you remember for section A, this was showing constant acceleration, and if you're remembering section C is constant deceleration. Okay, so this is constant deceleration. Now, how do we do these two? Is that you need to remember the four forces that act on the object. You're always going to have these two. Make sure they're about the same height, because they cancel each other out. This is the amount of support that you get from the ground. This is the weight force that you could get due to gravity. Now, when it's acceleration, that means the forward force need to be significantly bigger than the reverse. So this is the thrust, or you can say engine force, and this is friction. Okay, so this is the friction force that will slow down the car, but because this thrust is a lot larger in quantity, like the size of the arrow is a lot bigger, so therefore it's going to accelerate. So the net force is not going to equal to 0, it's going to go this way. When it's decelerating, it's going to do the opposite. So you still have your, you still have your support, and you still have your weight. Make sure they're the same length. These two need to be the same length, but this time you have more friction going the other way compared to your thrust, so you're slowing down. So this is why it's decelerating, because there's more force going backwards and you would slow down. So yeah, that's the drill. Wait, am I doing for section C? Yeah, section C. So how as it decelerates, so they even told you the answer, it decelerates in section C. So you need to make sure that the length of the arrow is really, really important. Okay, so we're going to use it below to compare the. So we already kind of did that. So if you look at this particular graph, you can see that for section A, can you see how steep this is? This graph is much steeper than this one. So when you have a steeper graph, that means you have a larger gradient. Okay, so if you look at this graph, this is speed time graph. The gradient of a speed time graph is acceleration. So if you have a larger gradient, that means you have a greater acceleration. Okay, so if you have a greater acceleration, when we're trying to compare the net force, so if you look at A, it has a greater acceleration. That means it's going to have a greater net force. You're going to have a greater net force going forward, and that results in a greater acceleration. Okay, now if you look at section C, well, this is accelerating, it's going forward. Okay, and then for section C, it's going this way, as we saw in the diagram, because we are decelerating. That means the net force is acting to the left hand side, it's acting in the reverse way. Okay, but it's not decelerating as much as section A's acceleration. Okay, because the graph is not as steep. Okay, so here it is. You can see the slope is steeper, so that means you got a larger gradient that results in a larger force. So the acceleration in A is greater because, again, it has a greater gradient, it has a greater net force, and in section A the net force going forward, the section C is going backwards because that results in acceleration and deceleration. Okay, I think this is the exam. It's just getting easier and easier. So I mean, it's good news for you guys. So all the best, and hope you do well for the upcoming examinations. And if you haven't liked and subscribed, please do so to support the channel. And I'll see you guys next time. Bye bye.